Welcome to my first video. Today I'm going to be covering Wireshark packet operations, and I'm going to make a poll asking you guys what type of forms do you want me to cover. Today we're going to start, learn the fundamentals of packet analysis with Wireshark and how to find the needle in the haystack. In this room we will cover the fundamentals of packet analysis with Wireshark and investigate the event of interest at the packet level. Note that this is the second room of the Wireshark room trial, and it is suggested to visit the first room, Wireshark the basics, to practice and refresh your Wireshark skills before starting this one. In this room, we cover the basics of the Wireshark by focusing on how it operates and how to use it to investigate traffic captures. In this room, we will cover advanced features of the Wireshark by focusing on packet level details with Wireshark statistics, filters, operators, and functions. A VM is attached to this room. You already know how to use TryHackMe probably. If not, we're gonna just start the machine. So we're gonna start. Okay. So the statistics menu provides multiple statistic options ready to investigate, and helps users see the big picture in terms of the scope of the traffic, available protocols, endpoints, conversations, and some protocol specific details like DHCP, DNS, and HTTP, HTTP v2. For a security analyst, this is crucial to know how to utilize the statistical information. This section provides a quick summary on the process pickup, which will help analysts create a hypothesis for an investigation. You can use the statistics menu to view all available options. Now start the VM, open the Wireshark, and load the exercise pickup ng, and go through the walkthrough. I really love Wireshark, but there's also some really great tools like TCP dump, T-Shark. I really like Zeek, Network Miner. But Wireshark is the most famous one, and it's great. I use it all the time. Okay, so resolve addresses. This option helps analysts identify IP addresses and DNS names available in the capture file by providing the list of the resolved addresses and the host names. Note that the host name information is taken from the DNS answers in the capture file. Analysts can quickly identify the access resource by using this menu, though they can spot access resources and evaluate them according to the event of interest. You can use statistics, resolve addresses. So here you can see all the addresses how I just showed you. You have protocol hierarchy. This option breaks down all available protocols on the capture file and helps analysts view the protocols in a preview based on packet counters, percentages. Analysts can view the overall usage of the ports and services and focus on the event of interest. The golden rule mentioned in the previous room is valid in this section. You can right click and filter the event of interest. You can use the statistics, protocol hierarchy menu to view this. So it's basically all the protocols in the pickup. You see how many packets, the percent of packets. You also have the bytes, bits, and packets and bits. Usually don't really use this. Just to have a general overview. Okay, we have conversations. I already went through it. Conversations represent traffic between two endpoints. This option provides the list of the conversations in 5 base formats: Ethernet, IPv6, IPv4, TCP, and UDP. Analysts can identify all conversations and contact endpoints for the event of interest. You can use statistic conversations to view this info. Endpoints. The endpoints option is similar to the conversations option. The only difference is that this option provides unique information for a single information field: Ethernet, IPv4, IPv6, TCP, and UDP. Analysts can identify the unique endpoints in the capture file and use it for the event of interest. You can use the statistics endpoints menu to view this info. Wireshark also supports resolving MAC addresses into human readable format using the manufacturer name assigned by IEE. Note that this conversation conversion is done through the first 3 bytes of the MAC address and only works for the known manufacturers. When you review the internet, the Ethernet endpoints, you can activate this option with the name resolution button in the lower left corner of the endpoints window, like this. Okay. Name resolution is not limited only to MAC addresses. Wireshark provides IP and port name resolution options as well. However, these options are not enabled by default. If you want to use these functionalities, you need to activate them through edit preferences. Let's do this real quick. Preferences, name resolution. Okay, so we can activate it here if you'd like to. I don't really want to do it. Um, Besides name resolution, Wireshark also provides an IP geolocation mapping that helps analysts identify the map source and destination addresses, but this feature is not activated by default and you need supplementary data like the GeoIP database. Currently, Wireshark supports MaxMind databases and the latest version of Wireshark comes configured with MaxMindDB Resolver. However, you still need MaxMindDB files and provide the database path to Wireshark by using edit preferences and resolutions. MaxMind database directories menu. Once you download them and indicate the path, Wireshark will automatically provide you IP location information under the IP protocol details for the matched IP address. I personally tried to do this and I signed up for the website and everything, uh, but I still couldn't really get the GeoIP location like this. Uh, but it still showed me the country, the city. It's pretty useful. Okay, so investigate the resolve addresses. What is the IP address of the host name that starts with VDC? Okay, so for this, we're gonna go to statistics, resolve addresses. Okay, so the website, the IP address of the host name that starts with VDC, this IP, 199.232.24.A1. Okay, so what is the number of IPv4 conversations? Okay, so we're gonna go to conversations, see how many IPv4 conversations. So it's 435. What is the number of IP addresses linked with Kansas City? We're gonna go to IPv6, IPv4. You can see it is 4 IP addresses, so that is gonna be the answer. Okay, which IP address is linked with BlickNet as organization? So here we can see as organization. Look for BlickNet. What IP address is linked with BlickNet? It's gonna be like it's gonna be just remove the name resolution. Okay, let's continue. In statistics, IPv4 protocol details. Okay, let's continue. Statistics protocol details, IPv4 and IPv6. Up to here, almost all options provided information that contain both versions of IP addresses. The statistics menu has 2 options for narrowing the statistics on packets and containing a specific IP version. Analysts can identify and list all events linked to specific IP versions in a single window and use it with the event of interest. You can use the statistics, IPv, and the version you want, and the menu to view this info. Go to statistics, choose the IP, choose all addresses, for example. You can see all the addresses. the count, the rate, the percentage. Uh, Now you can go to statistics DNS. This option breaks down all DNS packets from the capture file and helps analysts find the view the findings in a review based on packet encounters, percentage of the DNS protocol. Analysts can view the DNS services overall usage, including R-code, opcode, class, query type, service, and query stats, and use it for the event of interest. You can use statistics DNS to view this info. Now HTTP. This option breaks down all HTTP packets from the capture file and helps analysts view the findings in a tree view based on packet counters and percentages of the HTTP protocol. The analyst can view the HTTP services overall usage, including the request, response code, and the original request. You can use this by going to statistics, HTTP, and basically you can apply to every one of the options, whatever you need. You can go to DHCP, DNS, HTTP, HTTP2, TCP, UDP, whatever you need. So let's answer the questions. What is the most used IPv4 destination address? We're going to go to statistics, conversations, IPv4. We're going to go to packets and filter for the most packets. Then we can see packet A and packet A to B and packet B to A. So the most used destination IP address is gonna be 10.100.1.22.23. What is the max service request response time of the DNS packets? Go to statistics, DNS, max service response request time, request response time. So it's gonna be 0.467897. What is the number of HTTP requests accomplished by rad.msn.com? We'll go to statistics, HTTP, low distribution. Here we can see filtered for rad. Like as a filter. Okay, so for rad.msn, you're gonna see for the two IP addresses is 209. Okay, let's continue to packet filtering principles. Okay. In the previous room, we covered packet filtering and how to filter packets without using queries. In this room, we will use queries to filter packets. As mentioned earlier, there are two types of filter packets in Wireshark. Filters in Wireshark, while both use similar syntax, they are used for different purposes. Let's remember the difference between these two categories. Capture filters. This type of filter is used to save only a specific part of the traffic. It is set before capturing traffic and not changeable during the capture. And display filters. This type of filter is used to investigate packets by reducing the number of visible packets. And it is changeable during the capture. Note you cannot use the display filter expressions for capturing traffic and vice versa. The typical use case is capturing everything and filtering the packets according to the event of interest. Only experienced professionals use capture filters and sniff traffic. This is why Wireshark supports more protocol types in display filters. Please ensure you thoroughly learn how to use capture filters before using them in a live environment. Remember, you cannot capture the event of interest if your capture filter is not matching the specific traffic pattern you are looking for. Capture filter syntax. These filters use byte offset hex values. and masks with Boolean operators, and it is not easy to understand/predict the filter's purpose at first glance. The basic syntax is explained below. Scope, host, net, port, and port range, direction, SRC, DST, SRC or DST, etc. Protocol, Ether, VLAN, IP6, ARP, TCP, and UDP. Same filter to capture port 80 traffic, TCP port. Can read more on capture filter syntax here and here. You have quick reference at capture filters. You can always go read this. Also, when you're learning Wireshark, you can just look at cheat sheets and learn the basics, and you will learn it very quickly. Then you can use it also in the T-Shark and the tools, CLI tools. And it's really useful for you to know. So I have display filter syntax. This is the Wireshark most powerful features. It supports 3000 protocols and allows conducting packet level searches under the protocol breakdown. The official display filter reference provides all supported protocols breakdown for filtering. Sample filter for capture port 80 traffic, TCP port equals 80. Wireshark has built-in options, display filter expression that stores all supported protocol structures to help analysts create display filters. We will cover the display filter expression menu later. Now let's understand the fundamentals of the display filter operations. A quick reference is available under the Analyze Display Filters menu. Here we can see the filter name, the filter expression, how it can be used in the search. You have comparison operators. You can create display filters by using different comparison operators to find the event of interest. The primary operators are shown in the table below. If you want, you can pause the video and read through it. Also, you can, when you're just learning Wireshark, always use cheat sheets by our side. If you forget anything or whatever, you have a lot of great websites to practice traffic analysis. One that I really like, besides TryHackMe and Let's Defend, it's malware traffic analysis. We have traffic pickups captured from real world malware and ransomware attacks. Note, Wireshark supports decimal and hexadecimal values in filtering. You can use any format you want according to the search you will conduct. Logical expressions. Wireshark supports Boolean syntax. You can create display filters by using logical operators as well. Packet filter toolbar. The filter toolbar is where you create and apply your display filters. It is a smart toolbar that helps you create valid display filters with ease. Before starting to filter packets, here are a few tips. Packet filters are defined in lowercase. Packet filters have an autocomplete feature to break down protocol details, which is really useful. Also, when you start typing anything, it just shows you all the options that contains it. It's really helpful. Okay, so we'll read the task above. Now, protocol filters, as mentioned in the previous task, Wireshark supports 3000 protocols, packet level investigation by filtering the protocol fields. So you have some more about all the filter types. You can see pictures showing you TCP and UDP, application level protocol filters, HTTP and DNS. Application level protocols filter help analysts filter the traffic according to application protocol level information from the packets. Application layer of the OSI model. These filters filter application specific information like payloads, link data, depending on the product type. You can basically search for anything in the pickup file using the search, but you just need to know what query to use. Okay, so what is the number of IP packets? We're going to filter. You can see the packets displayed. is 81,530. No, after I filtered for 20, to search for what is the number of packets with a TTL value less than 10, you're gonna use ip.ttl less than 10, search for it. What is the number of packets? 66. Okay. This is the number of packets which uses TCP port 444. Go to TCP port 444. 632. What is the number of HTTP GET requests? And do HTTP request method equals GET, and then TCP port 80. Okay, let's try with the filter they gave us. Okay, the 1K sensitivity. Okay. And then TCP port 80. It's gonna be 527. What is the number of type A DNS queries? So I'm gonna go DNS. Wait, what is the syntax for? So for this one, I have to search the web. Actually, you didn't know this one, but you can't always know everything. It's gonna be DNS query. Maybe DNSA. There's always an easier way to do it. What I found was DNS query something. So now, advanced filtering. So far, you have learned the basics of packet filtering operations. Now it's time to focus on specific packet details for the event of interest. Besides the operators and expressions covered in the previous room, Wireshark has advanced operators and functions. These advanced filtering options help the analyst conduct an in-depth analysis of an event of interest. Filter contains, HTTP server contains Apache, list all HTTP packets for packet server field contains the Apache keyword, finds all Apache servers. You have matches, you have in search a value or field inside a specific scope range, find all packets that use port 80, 453, 8080, filter upper, convert all HTTP packet server fields to uppercase and list packet that contains the Apache keyword. You have it with lower, you have string, bookmarks, and filtering buttons. We've covered different types of filtering options, operators, and functions. It is time to create filters and save them as books and buttons for later usage. As mentioned in the previous task, the filter toolbar has a filter bookmark section to save user-created filters, which help analysts to reuse favorite complex filters with a couple of clicks. Similar to bookmarks, you can create filter buttons ready to apply with a single click. Creating and using bookmarks. You can also save different filters you want to create to make life easier and for future investigations. Here you have details how to do it. You have profiles. Wireshark is a multifunctional tool that helps analysts to accomplish in-depth packet analysis. As we covered during the room, multiple preferences need to be configured to analyze a specific event of interest. It is cumbersome to rechange the configuration for each investigation case, which requires a different set of covering rules, filtering buttons. This is where Wireshark profiles come into play. You can create multiple profiles in 4 different investigation cases and use them accordingly. You can use the edit configuration profiles menu or the lower right button of the status bar and profile section to create, modify, and change the profile configuration. So now they want us to find all Microsoft IIS servers. What is the number of packets that did not originate from port 80? HTTP server contains IIS and did not originate from port 80. Problem is this just inverts if you like in coding. If you it's also pretty common in different filters in programs like this. You can just invert what you're searching for and you get the opposite. So it's going to be 21, number of packets that did not originate from port 80. Okay, so find all Microsoft IIS servers. What is the number of packets that have version 7.5? Okay, so find all Microsoft IIS servers. What is the number of packets that have version 7.5? I'm gonna go do HTTP server contains IIS. Now, something that is really useful and always use it, you just go to whatever you need, you click on it, apply as filter, selected, and we're gonna change it. Here we can see it is 71. What is the total number of packets that use ports 333, 444, or 999? So we can use the following. TCP. Okay. So it's gonna be 2005. What is the number of packets with even TTL numbers? I'm gonna use the IP.ttl. I'm gonna go here, copy this, replace it. I'm gonna search. The answer is 77,289. Okay, change the profile to checksum control. What is the number of bad checksum packets? Download the profile. 9. Do TCP checksum status equals 0. And the bad checksum number is going to be number of packets, going to be 34,185. Okay, use the existing filtering button to filter the traffic. What is the number of displayed packets? The button, you click the button and shows you whatever this filter is, and the answer is going to be 261. Okay, so we finished this room, guys. Hope you enjoyed the video. Although I didn't really like the monotone type of videos, just reading it and answering the questions, I'm gonna do more interactive rooms and more interesting rooms. I'm not just gonna do random rooms. I'm gonna do polls and ask you guys whatever you wanna see make videos about. I'm gonna also make a lot of videos on different topics, different attacks, um different everything in the cybersecurity field. Blue team, red team, and I hope you enjoyed the video. If you did, please make sure to subscribe, like the video, comment, share with your friends, share on LinkedIn. Thank you very much for watching. I'm gonna see you in the next video. Peace.